Hey folks, Doug Blake with Body Design University. Welcome back to another weekly study. And again, this week we're going to be in chapter 7 again. This is the human movement science chapter. And of course, it is the sort of the bane of existence for most students that don't have any anatomy, phys, or exercise science background, and we get it. And I've said it before, NASM, I believe, did actually a pretty good job in kind of putting a lot of information. Just keep in mind, as a brief introduction to this, human movement science is a field of study all unto itself. And so you've got to keep in mind what they are trying to do, like any of the other NCCA accredited organizations that provide certifications for trainers. They're just trying to collapse literally, an entire field of study into a very small fractionated area in their textbook. And so you just got to kind of understand that a lot of the terminology that they're giving you they've tried to simplify it as much as they can to make sure you understand some basic concepts, which you do have to know, but without going too far into the field itself, and keeping the terminology basically at its simplest. Again, that's kind of the idea. When we get to something like the stretch shortening cycle, look, you can literally go on, Google it. I mean, if you want to Google the concept of the stretch shortening cycle, you'll come up with a million hits, from research studies to other well-educated trainers, individuals speaking about it. Again, as part of this introduction to explaining this to you, just keep in mind that the stretch shortening, I'll get it straight, the stretch shortening cycle really has relevance when we're talking about what NASM will get into, obviously, quite a bit more in the textbook. It's really relevant to plyometric training. Okay. And that's really the key here, is that understanding, if you're going to understand, right, outside of taking the exam and passing the exam and simply knowing how to answer these questions, outside of that, if you're going to be doing plyometric training with clients, which, by the way, I don't recommend you do it with clients. It's really designed for athletes. Now, there obviously are other uses for plyometric training. It's being used quite extensively now in post-rehab for athletes and for other individuals based on the orthopedic issues that they may have had. And so, again, without getting too far off base, just understand that when you're reading through this material, and that's why I'm not doing an actual PowerPoint, because just go to your textbook. And if you have your textbook online, that's fine. But look at the textbook and go through this. Again, I am normally going to do this, me personally. If I'm confused about something or I'm trying to memorize something, I'm going to write it down. I'm going to look at the material and write it down. So that's my recommendation. That's why I'm doing this for you, is literally to show you how I personally would be doing it. It's very effective for memorization. Of course, use whatever techniques are appropriate to your particular learning style and the way you memorize information. I don't just do it. By the way, I don't just write it. I will look and I'll try and picture things in my mind. I'll also draw pictures while I'm doing it so that I get a better understanding of exactly what it looks like in sort of a three-dimensional scenario. When you get to the stretch shortening cycle, however, there's some basic terminology you need to know. And by the way, this is based on a question. I saw that Robert had actually posted something in our Facebook group, and he showed the question. It is sort of the classic question on the stretch shortening cycle. During what phase of the stretch shortening cycle do we have the, I think it's the conversion of elastic energy, or stored elastic energy, the conversion of stored electric energy into explosive movement or explosive contraction, or whatever the terminology is used. And basically the question, and Robert, I think, had asked, is the amortization phase an intermediate or a conversion phase? And the answer is yes. But I will say this, I definitely understand, because remember, these questions that NASM asks can be confusing. And quite honestly, some of them are not asked particularly well, in my humble opinion. They could be asked a little bit more precise. There could be more precision to some of the questions. This question has that feel of ambiguity about it that can make you say, well, now, wait a minute, the initial conversion, if done correctly, would be at the or during the amortization phase. But keep in mind, the amortization phase of the stretch shortening cycle is by de facto as short as is possible to get the maximum conversion of elastic energy into the concentric contraction. That's where the question can get a little confusing. You could make a case, right? You could make a case that the answer to the question is the concentric contraction. Why? Because, the eccentric loading phase packs the elastic energy into the amortization phase. But if that amortization phase lasts any longer than a brief instant, believe it or not, you lose all of that elastic potential energy that could have been converted into, obviously, the kinetic energy that we see in the actual concentric contraction. I'm not saying that if you read through the research and you read through the more in-depth, precise, or more in-depth analysis of these three phases, you would get that. You wouldn't actually, if you read through it enough. The problem is that, of course, NASM is trying to condense information into a, essentially a page or a page and a half. It does okay, but it doesn't do full justice, and that's why I wanted to go through this with you. My my answer to the question of, well, why is it the amortization phase and not the concentric phase, is pretty straightforward. And you're not necessarily going to get, a really hard, fast feel for that answer just based on what they write in here. So if you're on page 209 at the stretch shortening cycle, and this is in chapter 7 again, if you read through this, I would recommend go through it and write down, as I've always suggested, write down the definitions and try and really understand and appreciate exactly what these definitions are saying. And there are a couple of terms in here that are critical to help you understand why it's the amortization phase and not the concentric phase. And that's really all I'm doing in this short video, is to help you to appreciate that. And the answer is that when you get to a couple of these terms, like series elastic component of muscle and tendon, mostly tendon, what you start to appreciate in the muscle itself is that a muscle contraction is not just one thing happening. It's not just muscle tissue, the sarcomere shortening and lengthening, for instance. No, there's a couple of other elements. In fact, there's more elements than what NASM actually says in here, but again, it would take you down too many rabbit trails. The reality is that there's two main ways or combinations for muscle tissue to actually shorten. Okay, one is the contractile machinery. Those are the things we call muscle cells, right? So you have muscle cells, actin and myosin filaments within the sarcomere, right? And they lengthen and shorten because of the interaction between myosin and actin, blah, 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 right? So you have the contractile machinery. They work irrespective of the non-contractile stuff inside your muscles, right? The tendons, the ligaments. By the way, the other proteins that are found within, the structural proteins that basically hold the myosin in place. It's like a webbing inside, and all of these proteins, right? Elastin and collagen, which are obviously located in the tendons and ligaments, but I'm talking about within the sarcomere itself. You don't just have actin and myosin filaments. You've got titin and a couple of these other proteins that actually themselves have a level of rigidity and some component of elasticity to them. So they will actually brace and bracket the actin myosin interactions as they are lengthening and shortening. So there's a number of non-contractile components, but the main ones that NASM wants you to see are the tendons and ligaments, mainly the tendons, because that's where the transmission of force from muscle contractions to the bone, right, and the movement of the bone occurs. So what the stretch shortening cycle tells us is that under these very specific conditions, where the eccentric phase is now you're going through the negative phase, but you're going at a speed or under a load high enough to create elastic energy buildup inside the non-contractile components. Once again, you got a page they've got a page to explain this to you. And again, they do a fair job on it, to be honest with you, but it's going to help if you can now look a little bit beyond this and understand this concept of what's known as series elastic components. And what we're talking about here are the non-contractile components of the muscle itself. So again, the muscle can shorten and lengthen all on its own just from the neurological activation of motor units via transmission of neurological response to the actin myosin filaments within the sarcomere, and they go whoop, and they lengthen, they shorten, and they lengthen. Okay, no big deal. However, there are these non-contractile or elastic components, elastic meaning they're stretched, and that's why they give you the helpful hint of a rubber band. It's a really good analogy. If you combine these together, right? If you combine the contractile machinery, the actin myosin filament shortening, with an additional sort of think of it like nitrous oxide in a car. You ever see a race car where you have your gas and you have your gas pedal and your car runs forward just on gas, right? Through the internal combustion, but then it in a nitrous oxide addition vehicle, you simply flick the switch, press the button, and then this new chemical called nitrous oxide goes into the engine, increases the combustibility and all the other mechanical elements of nitrous going into your car, and the car now speeds up. So essentially what you're doing is you're adding another element to the already established mechanical component of a car engine, just as a matter of fact. Well, it's the same thing with muscles. Muscles have their already normalized or normal contractile machinery that allows the muscles to go negative, positive, eccentric, concentric. However, there are these other elements that can assist or bolster the concentric contraction, and that's what the stretch shortening cycle is speaking to. It's just that if you think about it, there is a negative or one movement, right, of the muscle. It lengthens. It's like you're lowering your arm down and your bicep lengthens. But then there's a point where the direction changes, right? So there's this lengthening of the muscle, and then there's a point where it stops, and then it has to move through the concentric. So if you think, I always explain it as movement this way, pause, movement the other way. Eccentric, muscle lengthens, pause, and then the muscle shortens, concentric contraction. What the stretch shortening cycle explains to you is that there's something very special that happens in that pause. Now, I'm going to tell you right now, you don't use this concept or even consider this concept unless you're doing generally plyometric training. Why? Because when I'm training somebody, right, rabbit trail, when I'm training somebody, I'm not doing plyometric training with average people. I'm doing that with athletes, specifically athletes. Occasionally, I may do it for fit clients. There's no real reason unless you have some specific reason to do it. So I'm not going to do that with average clients. I'm doing everything smooth and controlled. In fact, I am limiting, if not eliminating, that stretch reflex when I'm actually training people. I am not doing bounding leaps, depth jumps. I'm not doing that with the average client. And so this has little to no relevance at that point. However, if you're dealing with athletes and you're going to do plyometric training, which I'm not saying don't do with athletes, of course you do it. It's a critical component of their periodization schedule. But what I'm saying is that in order to understand it now you got to step into this very special short period of time known as the amortization phase. It's when the eccentric gets converted into the concentric without an increased elastic potential energy load during the eccentric phase. Without that, you have a normal contraction. That's what happens when you have a bar on your back and you go down smooth and controlled and you pause at the bottom and you move back up. There's no amortization element there that's assisting with the concentric contraction. I hope that makes sense. You get it? If I go down smooth and controlled and back up, smooth and controlled, there is no eccentric load that's going to now put increased elastic potential stress on the tendons to be increased or to help increase the concentric contraction and increase power. That's just not what we're interested in. However, I'm doing a squat and I start to come down. I'm doing this with an athlete for instance, if I wanted to, I'm just giving you an example. I can come down, and as I get to that bottom position, I tell them to kind of just drop and bounce. What would happen? As long as they don't get injured, they would have an increased concentric power output. Why? Because that little bit of stretch that is applied as you're going down in your negative, that little bit of stretch on basically the tendon does what? It initiates an increased response by the muscle spindle fibers. And that's why you got to understand some of the terms. So if I can get, and this is where I always explain plyometric training, if I can get the muscle spindle fibers to actually increase their ability to get the muscle to contract, because that's what they do, right? They tell the muscle to contract because of specific environmental stuff that's going on in the muscle. So if I can get the muscle spindle to assist and help, now I've got basically three things occurring. I've got the muscle itself, right? The actin and myosin doing their normal thing and they're going through their concentric. I also have now the muscle spindle or the stretch reflex increasing neurological stimulation to the muscle. And on top of that, I have these non-contractile components of the muscle, i.e. essentially collagen and elastin proteins inside, right? The tendon itself, giving me this increased kinetic energy because of the buildup of the stretch elements of those particular components. Hope that makes sense. I got the muscle doing its normal thing, but that muscle gets accentuated by the muscle spindle fiber increase. So now I get even more motor unit recruitment. And this is all plyometric training. But there's also this other part of the muscle, the series elastic components, right? The tendons, for the most part. All three of those now are doing one basic thing, giving me more contractile power during the concentric or the shortening phase of the muscle contraction. And that's kind of the goal, right? So that's why we do plyometric training. There's many different ways that you can include plyometric type training, right? You can do low load, high speed components to your plyometric training. You can do high load, right? More power or force demands, okay, two basic ways that we do that or incorporate that plyometric component to somebody's program. Athletes, folks, I'm just telling you, real world athletes, that's what we do. Average clients, we ain't doing this anyway, to be honest with you. It's just too potentially dangerous. And you could definitely hurt somebody doing it. So the answer to the question of during what phase do you have this transmission of potential elastic energy converting into essentially kinetic movement energy during the concentric phase is going to be in the amortization phase. Look, if you find this is what I study. This is amazing to me. It's just an incredible field of study. If you find it that interesting, then for sure, go ahead and take a sideline after you pass the exam, after you pass the NASM exam, and look more into it, because you may find more interest in working with athletes more so than average clients. And if that's the case, then you definitely need to know this information. So when you're going through chapter 7, again, one of the benefits of having the textbook in front of you and having the resources available to you that we try to provide at BDU, the benefit of all this is you can spend a little bit more time or spend less time on the particular areas that you find interesting. And then also keeping in mind that you definitely want to focus on those areas, whether you're interested in them or not, those areas that we know are more heavily represented on the test than others, and don't get sidelined. There may be a question or two on this particular subject. I hope you also get the idea that just understanding how to study or learn this should help you in these other areas, because if you continue and move forward in chapter 7, you're going to get to more areas that could be a little bit challenging, like the force couple relationship, force velocity curve. And again, I know, because I talk to students all the time about this. I don't get it. I'm moving on. Boy, I sure hope I picked the right answer on the test. And that's one strategy. I would highly recommend that you pick a different strategy, right? Depending on how much time you have to study for the exam. But again, the point is if you're having questions on something like this, do it Robert did. Throw it into the Facebook group, or ask a question on our YouTube channel as well. And we'll try to answer it through a video. What Robert did was he threw a picture of it. And that's one of the best ways to do this, because then we can specifically look at the issue itself. So again, great comment, question on Robert's part. Again, stretch shortening cycle, eccentric, amortization phase, concentric. The concentric phase simply has what's known as the loading phase. This idea that you're compressing a spring, boom, and then the spring itself has this innate ability to rebound back. And that occurs in what's known as the amortization phase. It's in that amortization phase that you have this immediate. The goal of this, remember, is to reduce the amount of time between the eccentric and the concentric, right? This loading phase, to ensure that the elastic properties of the tendon are now maximized and brought into the concentric contraction itself. Just keep in mind that amortization phase, if it lasts too long, you get none of those elastic properties built into the concentric phase. Basically, it's lost as heat, friction. And so we're talking literally like split second. That's why we do depth jumps. That's why we do, hops and leaps. Those things need to be quick and moved into the concentric phase almost immediately. And that's the only way this really works. And so I hope that answers that basic question. If you do have any other questions on this particular topic, or of course any other topic, please just let us know. Post it in the Facebook group, or if you have any comments in our YouTube channel, then of course we are more than happy to respond and help. Remember, at Body Design University, our goal here is to help you pass the NASM test on the first go around. If it's not your first go around, okay, then your second, or wherever you are at. We're here to help. Thank you again. Have a great weekend, and we'll see you next week.